Hey everyone, welcome to the Tom's Hardware Podcast for February 1st, 2022. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, and I'm joined by Raspberry Pi expert Ash Hill, Associate Editor Les Pounder, and our two very special guests today, Richard Hayler and David Honess, who are responsible for the Astro Pi program, otherwise known as Pi in Space. Okay, I said it, so you don't have to. Uh, so we have some questions, of course, for them, and we're taking your questions live about the Astro Pi program. So for those who haven't seen Richard, who was on here before, and David, who hasn't been, let's can you guys introduce yourselves and tell everyone what your involvement is with the Astro Pi program?
Sure. Hi again, everyone. My name is Richard Hayler. I work at the Raspberry Pi Foundation, and as part of my role there, I've been working on Astro Pi for a couple of years. Most importantly, recently working on the new hardware that has just this week finished being commissioning on board the International Space Station.
Wow. So by finished commissioning, you mean that it's live on the International Space Station right now?
Yeah, so we had some amazing footage of the Astro Pis coming out of their bags where they've been sent onto the space station. The last time I saw those devices, I was putting them into a box in our office in Cambridge, and then to see them being on a pack was amazing. Since then, they've been plugged in. They've run all our self-test software that we created to check that everything was still working. And both of the units have had their turn in one of the windows of the International Space Station, taking photographs of Earth. So we've got back for the first time those brand new photos taken with the Raspberry Pi high quality camera. So we can see how amazing this year's competition is going to be.
Wow, amazing. So David, what's your involvement with Astro Pi?
So I originally, a few years back, I used to work for the Raspberry Pi Foundation, and I was involved in the Astro Pi that went up with Tim Peake's mission in 2015, and since then the challenge has gone from just a UK wide challenge to like a pan-European wide challenge. For subsequent ESA astronaut missions after Tim Peake. And then in 2018, I moved over to the Netherlands and started working for a company called HE Space Operations, and I'm contracted to ESA Education, and now working there. And my role is to coordinate educational operations on the International Space Station, one of which is Astro Pi. And and as Richard said, the last few years have been taken up by working on Astro Pi Mark II, and doing all the kind of the coordination and the paperwork and the safety documentation for that payload. It's been a really interesting time the last couple of years.
Wow, fantastic. I mean, it's really exciting that the second generation is there. So for those who are tuning in and want to have their program run on Astro Pi, who's eligible, and when and how does the contest work?
There's two strands. Oh, thanks. There's two strands to Astro Pi. There's Mission Space Lab, which enables teams of young people from across Europe and other eligible countries to write a program to run an experiment, and they get 3 hours of runtime on the Astro Pi flight units that are up there on the International Space Station. That's actually closed for this year. The submission deadline for that was in September, and we're midway through that project right now. But still running is a program called Mission Zero, which is a slightly smaller scale challenge where basically you can spend an hour or so creating a program that will run for 30 seconds on the Astro Pis that we've just newly sent up to the International Space Station. You have to write a program in Python programming language. You don't need any hardware. It's all run through Trinket and through a web browser emulation. And as a bonus this year, you get the opportunity while you're taking part in that competition to actually come up with some suggestions for names for the 2 new flight units up there.
Have you had any good suggestions so far?
Well, we have. So the criteria for suggestions is they need to be European scientists or engineers or something to do with that kind of field of computer science. So within the competition, we've suggested quite a few names, but we're seeing lots of people coming up with suggestions of their own, particularly scientists and engineers that are well known in specific countries and maybe don't have as much of a global fan base as some of the obvious ones we've suggested.
Has anyone nominated Pete Lomas yet? Just to name one of the Lomas.
Yeah, no, I haven't seen that, Les. That's a nice idea, though. He'd certainly be eligible, I think.
Richard, on the subject of getting involved with Astro Pi, what advice do you have for newer, inexperienced students who maybe want to make a project that could be submitted to Astro Pi?
I think the first thing is definitely give Mission 0 a go, because that gets you a good sense of what's involved writing a Python program to use the sensors on the Astro Pis to collect data, which is really what's at the core of the bigger Mission Space Lab project. So give that a go, and definitely have a look at some of the projects we have on our website and some of the information that's on the ESA website that just tells you a bit of the background and gives you the context of the Astro Pi program, what kind of things you can do, what kind of things aren't possible, so that when the Mission Space Lab opens again for entries, which will be in September 2022, you've already got some ideas in your head about what you could do with the hardware that's up there.
That's
Just
cool.
to add to that, there is actually also on the ESA website, there's usually there's a number of pages which list all of the winning Mission Space Lab entries going back through all the years, and we often say to people to go and have a look at what projects were in the final 10 to sort of get some inspiration, and then you can get a bit of an idea of what the capabilities are and what's worked in the past, that kind of thing, and that can sort of help frame your thinking for designing your own experiment.
Nice. Well, David, it's good that you're talking now. So I want to link into this. This whole series of shows is all about the past of Raspberry Pi, where it's come from in 10 years. Now, when you think of single board computers, you don't really think sending them to space and putting them on an international space station. You think it's going to be a robot or just tucked away in a drawer. So I want to know, how did it come about? How was the pitch to say, hey, can we put some Raspberry Pis in a rocket and fire them into space? How did it all come about?
Okay, so it was actually kind of by accident. So basically, I just started at the foundation. It was early 2014, that sort of time frame, and Eben sent an email around the office saying, I'm going down to meet some people at Airbus Defence and Space in Stevenage today. Does anyone want to come? And I just put my hand up and went, like, yeah, I'll come. And we went and had this meeting at Airbus Defence and Space, and the discussion was mostly on kind of using Raspberry Pis and especially compute modules on small satellites, like CubeSats and that kind of thing. But one of the people present at that meeting was the head of mission concepts for Airbus Defence and Space, and Airbus is part of a consortium called the UK Space Trade Association, and at that time that trade association was trying to, as a unit of all the companies that are a member of that association, they were trying to think of what they were going to contribute to Tim Peake's mission, which was in development at the time. And essentially what happened was we had that meeting. It was all discussions about different types of CubeSat applications and radiation tolerance and things like that. And then a few weeks went by, and what I didn't know had happened in the background is that this guy who was the head of mission concepts had then spoken at the next meeting about the what the contribution to Tim Peake's mission would be, and basically they wanted to propose sending Raspberry Pi as the their contribution to Tim Peake's mission. And the next thing that happened was I was invited to a meeting through the contacts that I'd made at that meeting at Airbus to another meeting with the UK Space Agency, and essentially I went into a meeting room with Libby Jackson and Jeremy Curtis, who they have sort of they're quite senior in the UK Space Agency, and essentially Tim Peake's mission was on the table, and we were discussing how to, what the kind of parameters of the mission would be, and there was a very kind of sort of a bit of a conservative atmosphere about that. We didn't want to go too far. We wanted to make it so that it was like small and self-contained and easy to deploy. And essentially what it was going to be a Raspberry Pi on the space station, which would have a preloaded SD card with some experiments written by students, and it would boot up, run those experiments, and then they would take the SD card out, put it into a laptop to download the results. And there's no networking or not connecting it to anything, if you see what I mean, just for that mission. So that's kind of how it got started, and then what followed was building the education program around that, and creating a website, working out what the parameters of it would be. And at that stage, Mission Zero didn't exist. It was originally conceived in a very similar vein to what Mission Space Lab is like now, but only for the UK to participate in, if you see what I mean. And the actual scope of what it would do on the space station was literally just to boot up, automatic run all these experiments that would be run, and there were only going to be about 20 or so of them, if you see what I mean, at that stage. And then the crew would just shut the Astro Pi down, take the SD card out, and download it via an SD card connected to another computer on the space station. So it was actually quite small in scope. But of all of the things that were part of Tim Peake's mission, it was one of the most complex, because in terms of education, because it actually had to plug into the space station and consume power from the space station. So a lot of the other contributions were things like video messages or demonstrations of different types of physics in microgravity, whereas the Astro Pi was actually an electronic device, had to go through all kinds of different qualifications and tests and things. So yeah, that's basically how it started. It was kind of, there was no kind of flash of brilliance. It was kind of, it kind of evolved, if you see what I mean. I kind of feel like I was in the right place at the right time.
So we have a viewer question asking about, what about phantom interference in the GPIO?
Has it been addressed on the pull-up resistors? I'm not aware of any interference on the GPIO. They do have built-in pull-up resistors that you can set programmatically. Obviously, the biggest thing about them being in space is the radiation environment, and ionizing radiation going through, say, RAM or a CPU is known to cause what's called a single event fault interrupt, or a single event upset, or things like that. There's lots of different types of these things where basically the kinetic energy from the particle going through the electronics can actually impart energy into it and, say, flip a bit from a 1 to a 0 or a 0 to 1. That's the usual kind of things that you get with being in space. The GPIO has never been a issue as far as I know. Have you seen anything like that, Richard?
No, not at all. As you say, I think the big concerns in terms of interference with the Astro Pi are obviously from other radiating things on the space station, and we carry out quite stringent checks as part of the electromagnetic susceptibility test we had to do for the new hardware. And as you say, the ionizing radiation issue is something we're keeping a close eye on, because the Raspberry Pi 4, which is in the new hardware, compared to the Raspberry Pi Model 1 that's in the old hardware, has there are far more and far larger chips on there. So almost there's a bigger target for any particle to hit it and cause disruption.
Yeah, I think it's a 24 nanometer die, and the Raspberry Pi one's a 40 nanometer. So just by that, it's about, I don't know, a 35-ish% size reduction. So the actual, the tracks within the CPU floor plan are physically smaller, and are therefore technically more vulnerable to an upset. But we haven't really seen that so far. So obviously they're being monitored from ground. They are connected to the LAN on the space station, and we have a user operations science center in Switzerland that are constantly monitoring it. Every day or two they can just basically SSH in by bringing up a couple of VPNs. They can get IP access directly to it, wherever the ISS is in its orbit, and they can keep going in and downloading the syslog and just operating it like you would operate a remote Pi on ground.
Richard, sorry, question for you, because the new Pi 4s inside the new Astro Pi units, and the original Pi that was in was the B+, remember rightly, wasn't it, Dave?
Yep.
Yeah.
So obviously with the Pi 4, we've now got Wi-Fi and Bluetooth. So do you need more certification, say it's not going to interfere with the systems on the ISS?
So in the new hardware, the actual onboard Wi-Fi and Bluetooth is disabled, which is why if you see the pictures of it, we've got an external Wi-Fi dongle we use. Dave's got on there, brilliant. So if you think about the case itself, this big aluminium case essentially acts as a Faraday cage. So we would probably have to really ramp up the power on the onboard Wi-Fi if we were to use it. It's much easier to just physically disable that on the board and then use the external Wi-Fi antenna. But going to your question is, we have to do a lot of certification around that.
I have a question for both of you, whoever wants to answer first. And I want to know more about these space-related challenges that you had to overcome to get the Raspberry Pi on the ISS. Specifically, were there any changes that had to be made to the Raspberry Pi itself to approve it for use aboard the ISS?
Yeah, so Richard just mentioned one actually. So we the onboard Wi-Fi, the little trapezoid shape that's cut into the PCB, for EMC compliance, and the EMC testing that you have to do is much more stringent on the ISS than it would be for sort of domestic products that you might sell on ground. They basically, I think I can't remember exactly how you guys did this, but Richard might be able to tell me. I think they might have cut one of the rails or shorted it to ground or something like that as a physical mod to make it impossible for that little trapezoid to oscillate and to radiate any kind of RF. And then on top of that, the actual flight case itself is quite a significant modification, and that's actually the reason it's so big and chunky is obviously on the bottom you'll see there are those heat sinks. And this is basically to create enough surface area so that it can dissipate, reject all of the heat that's coming from the CPU of the Raspberry Pi. So you can't just have a naked board up there, if you see what I mean. So any kind of electrical shock possibility or any kind of way that something might not be grounded properly or has to be properly dealt with. And the case is all grounded through the it's grounded through the shell anchor of the USB-C port. So there's actually a little kind of foil patch underneath one of the mounting holes inside the case, and that is soldered onto the shell anchor of the port, so that the entire flight unit and the case is all electrically grounded. So that's how it acquires its Faraday cage-like behavior. I'm just trying to think of any other physical mods that we did to the board. There's the obviously the mezzanine board. I wonder if we should talk about that, because that's not something that's usually ever talked about. So the actual stack in the actual inside the case, you've got the Raspberry Pi at the bottom, and then in the middle you've got this mezzanine board, which we can talk about now, and then on the top you've got the Sense app. Okay, and that board in the middle is often not talked about. On that board you've got a real-time clock and a backup battery. so that the Astro Pi can keep time even if it hasn't got network access. And there's also an interface for one of the sensors, the PIR sensor, and the 2 buttons, if you see what I mean. So that's kind of like an Astro Pi specific piece of hardware, which is only for the flight units, if you see what I mean. So that's not a board that's, I think, ever going to be available to the public. It's only something that's inside the actual flight units themselves.
And the other thing new this year is the SenseHat on the new hardware is a new SenseHat. So again, not commercially available, but if you notice on here, there's a window because the new SenseHat now has a light and color sensor on there, which some of the teams who've entered the competition this year are making great use of. So that's a new version of the SenseHat. And also you notice the difference between the Mark 1 and the Mark 2. If you can see the LED matrix on the original Mark 1 hardware, it's the bare exposed LEDs on the matrix. For the new hardware, we've put this film over it to just reduce the brightness of the LEDs. There's kind of 2 reasons for that. One is it makes photographing the LEDs a lot easier, but also the regulations around how bright something could be on the space station had changed between sending up the Mark 1 hardware and the Mark 2 hardware. So because technically those LEDs are capable of being really, really bright, we needed to put that film layer in front of it just to reduce the brightness, to make sure anyone who was looking at it for a long period of time couldn't possibly suffer any damage to their eyes or their retinas.
Yeah, I can attest to how bright the SenseHat is, because when you turn on a Pi with a SenseHat on, it's very bright.
Oh yeah, the rainbow. Yeah, you get the rainbow, don't you? Yeah. There's actually, I don't know if you guys know, but the crew are sleeping in Columbus at the moment. So there is actually a new sort of crew quarter chamber called Cassis, which has been installed in Columbus, and it's on the ceiling. So if you look at some of the pictures that Matthias Maurer is tweeting at the moment, you can see that his bunk, if you like, is on the ceiling in Columbus, and the brightness and stuff like that for the LEDs is when you want to sleep in there, you have to sort of try and turn down all the lights and things like that, so it's nice and dark so you can sleep. So all of those things have to be, anything that can affect the crew in any way, especially long-term exposure to things like bright light sources and loud noises or anything like that, are all very carefully controlled by the safety certification process that we had to go through.
So I guess this kind of begs the question of what this is only used, if this isn't used every day all year round, right? It only has certain windows of time when it's being used. And if that's the case, what do they do with it in the meantime?
So they stay on the network all the time.
Right.
So they're actually basically part of the furniture in Columbus, if you like. If you look at any of the pictures that have come out of Mattis's account in the second half of January, you should be able to spot them. You'll be able to see them on the side there. Usually on the, as you look at the picture, they'll be on the right-hand side. And obviously, people like me and Richard are always spotting them and looking for them and seeing where they are. And essentially they stay out because it saves crew time if they're already out when we want to actually, use them for something. And the Mark 1 Astro Pi has been in that situation also since 2015. They've basically been in almost every single photo of Columbus since Tim Peake was there, which is kind of amazing, really. But the practical reason for it is that it saves crew time because then they don't have to go to the stowage locations and look for it, if you see what I mean. Searching for things in stowage is often quite a bit of a time sink on the space station. And essentially we also keep them on because they are running Debian Linux. They're running the Raspberry Pi OS, which has been security hardened, and I think it's every quarter. Every quarter at minimum, they have to do all these antivirus and security updates on it, and so having it on means that the guys in Switzerland that monitor it from ground can always get into it and make sure that it pulls the antivirus definitions from this NASA server, which is also that it can reach, that's on board, and just to keep the OS maintained and everything like that. Nice,
cool. I'm going to take us back down to earth now, and the pun is intended for that. I want to talk about the history again. So we've had Astro Pi running now for, was it 2015 it started?
Yeah.
Roughly? I'm looking at the board in front of me to get the date on that. But the people who were messing around with it then, that was 7 years ago. They're now young adults. They've been to university, they've been to colleges, that sort of thing. Where do they go from there for their career if they want to go into space or engineering or something like that?
Well, this is kind of, the point of Astro Pi really is to try and, keep people interested in studying STEM subjects, with a view to them going on and, maybe one day working in the space industry. And that was, a lot of the focus on, certainly on the Principia mission, was about trying to create the Apollo effect in the UK. We all ended up calling it the Tim Peake effect, the hope was that by around, I guess, sort of now, the people that were impacted by that mission will be entering the employment market, sort of thing, not just for the sake of industry or for companies like ESA, but also for the people in the individuals themselves, because working in the space sector or working in engineering and science are generally very rewarding jobs. So I think I do vaguely remember making a bet with Tim at Farnborough Air Show in 2014, that I would phone him when the first person who got Astro Pi on their CV gets employed by ESA or by Raspberry Pi at the time. And I'm kind of like watching and waiting to see that if that's going to happen. I do hope that it will happen one day, so that I'll then try and get in touch with him to tell him that it's happened.
I think just on that, Les, one thing from my personal point of view is, before I started work at the Raspberry Pi Foundation, my first real sort of experience of the work they did was through Astro Pi. In fact, the first time I met Dave was when he was announcing the Astro Pi Principia mission competition at an education show in London. And I heard this and heard about the opportunity for young people to run their Python programs on the International Space Station. I just thought that was amazing, and immediately went back to my code club, which I was running at the time, and said, like, guys, we've got this opportunity to have our programs that we write run on the International Space Station. And I was lucky that the young people I was working with at the time in my code club were great, really enthusiastic and really talented. And so we were actually one of the first teams that won the Astro Pi Challenge in 2015. And I've sort of kept in touch with many of those young people over the years. They were all at primary school at the time. And so now most of them are doing their A-levels. And the majority of those young people are doing maths, physics, some kind of science-based subject. So I think, I remember when they left primary school and at the end of the year, they were filling in their yearbook, and almost everyone who took part in Astro Pi, when they were asked what thing they were most proud of their time at the school, it was having their code run in space. So for me, that was a really personal evidence of the impact things like Astro Pi have, and the impact it can have on young people and what they want to do in future.
I remember you showing me that scan of that handwritten sheet with them all writing Astro Pi, and thinking that there's definitely something in this, and it was just after that basically it was at the launch party that happened at the London Science Museum. I got approached, I was still working for Raspberry Pi then, by someone at ESA, and they basically said they wanted to make it go fully European, like the every ESA member state, because the hardware had a lot of money and an effort had been put into qualifying that hardware for the space station, and the view was that they could get more value out of it by sort of running that competition with a much wider eligibility field, if you see what I mean, and then when Thomas Pesquet flew to the space station, for his mission, we ran Astropy again, and still also without Mission Zero. Mission Zero only turns up in 2017, and we did Astropy all over again for his mission, where basically all ESA member states were able to submit proposals and to have code run on the space station. And that year, instead of it being about 20 experiments, I don't remember quite how many it was, but it was more like 200 or 300 experiments.
Wow.
So that was just in one, the difference between 2015 and 2016.
And if you look at the numbers now, last year, so putting together Mission Space Lab and Mission Zero, over 17,000 young people had their experiments run on the International Space Station.
Mm-hmm. And it was the numbers like that allowed us to justify doing Mark II as well, because the way I always try and calculate it is like, how much do we spend on Astro Pi, divide that by how many students it reaches each year, and then you've got your spend per person reached, and then because that comes down at, I think it was like €4 or something every time I've calculated it, it's been under €5. And then like the people with the purse strings at ESA are like, yep, so
the subject of just Astropy has inspired how Astropy has inspired so many kids since its creation, and like you said, they're joining the workforce now. Aerospace is filled with so many different areas of STEM. I want to know if you guys have any examples of any unconventional or surprising projects that students have submitted to Astropy.
I've got a few. Richard, do you want to go first, or
no? You go for it, Dave. We're probably going to say the same ones, so you go for it.
Oh, okay. Well, I was actually going to go for Sweaty Astronaut the first time, which is your experiment, and this was it was called Sweaty Astronaut, but we ended up I think we changed the name of it in the end. But essentially, it was a very simple experiment, just to measure the presence of the crew using only humidity as the sensor. And obviously, when they're working, they do sometimes. There was for a while an exercise machine in Columbus, and I think it was there that it was called MERS, the MERS machine. It's a muscle atrophy measuring machine, and that was on the left-hand side of Columbus. And basically, when they get into that machine and they start exercising, obviously they're perspiring, and that's actually the sensor on the sensor is sensitive enough to easily pick that up at a bit of a distance. So there are all these pictures that came out of that experiment. One of which Tim, obviously, when he first deployed the Astro Pi, he exhaled on it and then posed for a picture, and there's that picture, and then there's all these other pictures of him. There's one of him sort of like reaching up and getting a bag. There's one where all you see is his arm, if you know what I mean. And I just thought that was really, and that was primary school kids that did that, if you see what I mean. And I've always sort of like loved the simplicity of it, if you see what I mean. But there are more complex ones, but maybe we should just take turns. If I'll do one, and then and Rich, you can do one.
Sure. I mean, I think just jumping forward to this year with the new hardware that we've deployed, there's a whole bunch of teams trying to use machine learning now, and that was one of the aspirations for sending up the new hardware, was to make it much easier for the teams who we'd seen in previous years really struggle to do a decent kind of machine learning experiment with the old hardware. So now this year we've got lots of great examples of teams looking to do machine learning to identify various things on Earth, to classify objects, to classify clouds, to look for all kinds of changes in the environment that they can detect by taking photos of the Earth. And in fact, of all the entries submitted this year, over 50% do involve some kind of machine learning. And I think obviously that for me is a great success of the new hardware, and it shows that young people are really interested in taking these technologies and really pushing them to their limit with the fantastically unique set of data that you can only get through Astro Pi.
Mm-hmm, mm-hmm. And I'm just thinking back to another. There was a really good experiment that came out of France. I think it won a couple of years back, where and their report was amazing. I loved reading it, and it was they had basically written their own fast Fourier transform in Python, and they had like photos of the function of the code and everything, and they were really kind of proud of how they'd coded it and everything. And essentially, what they were doing, they were looking at the accelerometer, and they were sampling the accelerometer as fast as they could, basically in a tight closed loop where it's just banging out measurements from the accelerometer into memory. And then they were using the fast Fourier transform to convert that from time domain into frequency domain. And they were actually able to identify, this is a bit more of an older age group, by the way, they were able to identify a number of discrete vibrations at different frequencies. And this was really interesting. And basically, we never knew this. They actually did an experiment where they absolutely found out something new that we didn't know before. We were looking into it and like, what are these vibrations coming from? And they identified a vibration at like 14 hertz or something. And then we were looking around trying to figure out what was causing this vibration, and the vibration must obviously be translating up into the Astro Pi from the arm. And I don't know if you've seen this on the side. There are these little this little stainless steel plate is what is used to connect them to the bogan arms, the multi-use brackets, which hold them in position and hold them still. And those are bolted into the rack front using a little seat track, and you'll see there's seat track, vertical seat track in between each of the racks in Columbus.
Yeah.
And then we thought, right, okay, so it's getting a vibration from the rack. It's the rack vibrating, and then we realized that there's a centrifuge in Biolab, which is the rack that it's mounted on. And we actually checked, and the centrifuge was actually active whilst their experiment was on. And that vibration of the centrifuge in there, which is used to create different levels of gravity for a bio experiment, which would be inside there, was translating up the arm and into the Astro Pi, and then being measured by that accelerometer. So that really surprised us as well, and that was a very good, very unconventional and unique experiment.
I like how much work went into tracking down the source. I bet there was a lot of theories going around.
Yeah, that was all on us. The students didn't do that. We were doing that because we wanted to know, like, where's this vibration? So yeah.
Well, I want to thank our guests, David and Richard, for joining us, and of course, all of you who watch now and after the fact. We are celebrating obviously, for more, you can go to astro-pi.org. But we are here every Tuesday at 7:30 p.m. UK time, 2:30 p.m. Eastern, and for the next few weeks, we are having special guests to celebrate the 10th anniversary of Raspberry Pi. Les, who's our guest next week?
Next week, we've got Tim Richardson talking about Pi Wars, the non-destructive robot battle tournament that happens every year. And it's gone from strength to strength, that event. It really is great fun.
Well, we'll really look forward to that. Thank you again, Richard and David. It was an honor having you on our show, and we will see you all next week. Bye, everyone.
Right.